So first, I would like to consider parallel axis theory. First, I will explain you what is definition. I is equal to Ig plus m into d square. I will tell you each and every term, what each and every term signify out here. For that purpose, I am considering an arbitrary shaped object. It can be a plane body or a three-dimensional body, anything it could be. So for that, first you should locate what is its center of mass, and you should imagine an axis passing through its center of mass or center of gravity. Moment of inertia with respect to this axis, I am calling it as Ig. And one more axis, that axis may lie inside the body or it could lie outside the body also. This axis which I am considering, it can lie outside or inside. For simplicity's sake, I am taking it outside. Okay. So, or else I will take two axes in such a case. One is inside and another one is outside. Okay. So let me call it as Ia. Moment of inertia with respect to this axis, I am calling it as Ia. And another axis that I am considering is, which is passing inside. Let me call it as Ib. Okay. Then, moment of inertia. To apply parallel axis theory, how many Igs we can imagine? One axis passing through the center and existing in the plane of the board or in the plane of the object, and another one is perpendicular. This is also I am calling it as Ig only. But which Ig should I consider? Out of all possible Igs, which Ig should I consider? The Ig which is parallel to the given axis, which is parallel to the axis with respect to which I wanted to measure the moment of inertia. So it is given by, if the distance between this Ia axis and Ig axis which are parallel to each other, if the separation between these two is d, then what I can write? Moment of inertia with respect to the axis Ia is equal to moment of inertia of this object with respect to Ig, which is parallel to this axis and passing through the center of gravity, plus mass of this whole object m into square of the separation between these two parallel axes, that is d here, d square. Similarly, if you wanted to write it with respect to Ib is equal to, if the separation between these two axes, if I take it as small r, okay, Ib is equal to what I can write? Ig plus m into r square. So this is what all about parallel axis theory is. Now I would like to use this and apply to a configuration. First thing that I would like to consider is rod, because already in the beginning of moment of inertia lectures, I derived the expression for moment of inertia of a rod. One with respect to an axis passing through the center of mass and perpendicular to the length. I called it as Ig. We know this value. How much it is? M L square divided by 12. And I derived this also with respect to an axis passing through one of its end and perpendicular to the length. Let me call it as Ia. I derived it already. How much it is? Ia is equal to M L square divided by 3. By applying parallel, instead of doing integration and everything, by applying this parallel axis theory, you can calculate it. That I am going to show here. So I want it with respect to an axis Ia, which is parallel to the axis passing through the center of gravity and at a distance. What is the separation between these two? If this is edge and this is center of gravity, if the length of the rod is L, distance from here to here will be L by 2. Distance between these two parallel axes is how much? L by 2. So first I will write it as it is, plus m into, what is the distance between these two? L by 2 whole square. That is equal to, what is Ig? Already I calculated, ml square divided by 12. M L square divided by 12 plus m L square divided by 2 to the 4. That is equal to, if you take the LCM and simplify it, you will be getting it as ml square divided by 3 only. which I already derived. So instead of doing always integration, differentiation, all these things, by using parallel access theory, you can find the moment of inertia of rod like this. This is with respect to one of its ends. Same concept, I would like to apply it for a square. I would like to consider a square lamina. Okay, this is the square lamina that I would like to consider here. This is the square lamina. Okay, this is the square lamina. So with respect to its center of mass, passing parallel to one of its edges, that is this axis, that I called it as IG. Already we calculated it. How much it is? Because along this horizontal direction, it is very much like a rod only. So IG for rod and IG for this square lamina, both are going to be same only. If its mass is M and if its length is L, then IG is equal to how much you're going to get here? IG, which is parallel to one of its end faces, one of its edges, is given by IG is equal to M L square divided by 12 only, same as it is rod only. So similarly, if you wanted to calculate with one of the axis which is parallel to this IG and passing through one of its ends, that is with respect to this axis. Let me call it as IA. Same as this only. Same as this. That is how much? IA is equal to M L square divided by 3. So as far as moment of inertia is concerned, this and this same as it is we are getting. Am I right? Now comes the question. What is that? What is the moment of inertia of this square frame with respect to an axis passing through the center of mass and perpendicular to the plane containing these two, plane containing the lamina, that is with respect to this axis. So that is also passing through the center of mass only. That also I'm going to call it as IG only. But this IG is perpendicular to the plane containing the frame. So to calculate that, the technique, instead of doing integration process, I would like to consider what you call it as perpendicular axis theory. Perpendicular axis theory. Perpendicular axis theory. What is perpendicular axis theory? If you take any arbitrary shaped laminar body, be careful. Here I did not use the word laminar body. It is applicable to any body. But this perpendicular axis theory is applicable only to laminar bodies. Laminar bodies means two-dimensional bodies like this. So this dimension and this dimension, when you compare it, this dimension, this height is very much less. So this kind of bodies we call them as laminar bodies, two-dimensional bodies. Okay. So to calculate what is the moment of inertia of this laminar body with respect to an axis perpendicular to the plane of the body. Okay. For that purpose, first what you should know is, first you consider any two mutually perpendicular axes. Let me call this is IX and this axis as IY, that I am writing here. This horizontal axis I am calling it as X axis. This vertical axis I am calling it as Y axis. Okay. Be careful, this X and Y axis should exist on the plane of the laminar body. Okay, and now imagine an axis which is perpendicular to this plane and passing through the intersection of these two, that is like this, that I am calling it as Z axis, or else you can take it like this. This is the Z axis. This is perpendicular to the plane of the body, that is like this. If you take this as IX and this is Y axis, this is the Z axis. So with respect to this Z axis, that means if you rotate the body should rotate about this Z axis. It can exist at the edge, middle or anywhere, but it should exist within the body only, and it should pass through the intersection of these two axes. Then according to this perpendicular axis theory, what I can write, moment of inertia with respect to this perpendicular axis IZ is given by Ix plus Iy. That is, moment of inertia of a laminar body with respect to an axis perpendicular to the body is given by the sum of moment of inertia of two mutually perpendicular axes which are intersecting and passing through z axis. That is called perpendicular axis theory. Iz is equal to Ix plus Iy. Okay, now I am using this perpendicular axis theory to find out what is the moment of inertia of this square lamina with respect to an axis passing through the center of mass and perpendicular to the plane of this square lamina. Okay, so for that purpose, first what I will do is I will consider a square lamina like this. Okay, so this axis, this is the center. This axis I am taking it as x-axis. This axis I am taking it as y-axis. Okay, so in this direction, if you look it from top to bottom, okay, this is going to be half of the length, L by 2. Then what is the value of Ix? Ix with respect to an axis passing through the center of the rod. That is like this only, center like this only. That is how much? ml square by 12. So with respect to x-axis, Ix is ml square divided by 12 only. Similarly, Iy is equal to how much you will be getting? This is also from left side, it is at a distance of L by 2 only. So this is Iy. Iy is equal to same, ml square divided by 12 only. Now, with respect to this axis, that is the z axis, Iz is equal to, by applying parallel axis theory, what I can write? Ix plus Iy. That is equal to, what is Ix here? ml square divided by 12 plus ml square divided by 12. That is equal to, that implies Iz, which is nothing but Ig. I am calling it as this Ig are different. Be careful. This Ig is lying in the plane of the laminar body. This Ig is perpendicular to the plane of the laminar body. How much you are getting? ml square divided by 6. This is by applying perpendicular axis theory. This is how we apply parallel axis theory and perpendicular axis theory, and we can find out with respect to any axis. As an observation, if you take this is point A, this point as B, C and D. What is the moment of inertia of this configuration with respect to an axis passing through the diagonal? That is like this. With respect to this axis, I, B, D I want. How do you going to do it? So for that purpose, again I am drawing the diagram over here. Just have a look at it. This is the square lamina that I am considering. Okay. Now, with respect to this axis I want. For that purpose, what I will do is, I will take two mutually perpendicular axes along the diagonal. Okay. This is one diagonal axis. This is another diagonal axis. And here the technique involved is, because in a square, these diagonals are perpendicular to each other. So if you take, now I will take this as x-axis and this as y-axis. Now, what happens then? This is Ig. Ig is perpendicular. So this Ig and this Ig which I calculated here, both are same only. So here I know the value of Iz to calculate with respect to what is this? A diagonal AC or a diagonal BD. Both are same only. BD. So with respect to what I am calling it as IAC, which is nothing but IBD. I wanted to calculate this only. So to calculate this, what I am doing is, I am taking this diagonal axis as x-axis, this diagonal axis as y-axis. Can I take it? Yes, obviously, because in a square, these two diagonals are perpendicular to each other. So because of which I can apply perpendicular axis theory. Here, what is z-axis? Ig, which is perpendicular to the plane of the lamina. Just now I derived here. How much it is? Ig. Therefore, Iz is equal to, which is nothing but Ig here, is equal to, how much you are getting here? ml square divided by 6 is equal to what I can write? Ix plus Iy. But out of symmetry, what I can write? Ix is equal to Iy, through which I can write 2 times the Ix is equal to what I can write? ml square divided by 6. Therefore, which is Ix, which is nothing but IAC AC or IBD is equal to how much you will be getting? M L square divided by ml square divided by 12. So this is how I calculated for a square frame by applying combination of parallel and perpendicular axis theory. If it is possible, you can do like this also. Again, I am considering square frame only. This is a square lamina. Okay, I want to find out with respect to an axis passing through A, B, C, D. But this is perpendicular to the plane of the board, like this. With respect to an axis passing through, that is one of the corner and perpendicular to the plane of the board. So for this purpose, what I will do, I will consider parallel axis theory, or you can use perpendicular axis theory also. But if you take perpendicular axis theory, IAB you should take it as x-axis, IAD you should take it as y-axis, and this IA, that is IA, passing through A and perpendicular to the plane of the board, IA is given by IX plus IY, because in a square frame these two sides are perpendicular to each other, because of which I can apply it like this. So therefore IA is equal to IX plus IY. Already you know with respect to one of its ends, what is the moment of inertia with respect to one of ml square divided by 3 only, that is equal to ml square divided by 3 plus ml square divided by 3. Therefore IA is equal to what you can write, 2 ml square divided by 3. Okay, so this is how, by applying combination of check it whether this is correct or not by applying like this. Now I can solve same thing by applying parallel axis theory also, because IA is one axis and IG is another axis. These two are parallel to each other, and distance between these two is how much? Distance from here to here. This is D here. Okay, so by applying same IA, I am calculating by applying parallel axis theory. How can you calculate it? IA is equal to IGE plus M into D square. That is equal to IG. Just now we calculated IG is equal to ML square by 6. M L square divided by 6 plus M into D. This D is how much? L by 2, L by 2, root 2 L divided by 2. Root 2 L divided by 2 whole square. That is equal to how much you gonna get? M L square divided by 6 plus M into L square divided by 2 you will be getting, because root 2 whole square is 2, 2 square is 4, 2, 4 gets cancelled, you will be getting 2. That is equal to how much you will be getting? 4 divided by 6 ml square, which is nothing but m l square divided by 2 by 3 ml square. So if you compare whether you calculate it by applying perpendicular axis theory, by applying parallel axis theory, both of them should come same only. This is the overall thing regarding moment of inertia of a square lamina. Thank you.